we want to look at a couple theorems that help us in solving polynomial functions. So when we solve a polynomial, right, the idea is that we want to find where the zeros are. So to do that, we're going to use a combination of three different theorems. The first theorem we're going to look at is the remainder theorem. So the remainder theorem basically says that when I divide a polynomial by any linear factor, the remainder is the same thing as if I were to evaluate. So basically this remainder theorem in layman's terms means that if you divide by a linear factor, which remember when we divide by a linear factor, that means that I was using synthetic division. So when I'm using synthetic division, you could also just plug in or evaluate with that same number. Remember, evaluate just means to plug in. Okay, so we're going to do that and see how both work. The reason we want to use this is because sometimes we might want to use synthetic division to get the remainder. Sometimes we might want to just simply plug in the value to get the remainder. Okay, because here in a few minutes we're going to talk about when the remainder is a specific number, it means something. Okay, so let's just look at evaluating here and synthetic division. Okay, so using the remainder theorem, let's say that we had the function 3x cubed minus 2x squared plus 5x minus 1. And we wanted to divide that function by x minus 2. Okay, so before we looked at this and we said, okay, well, that means that I can use synthetic division. Using synthetic division, I'd take this divisor and I would say, well, x minus 2 equals 0, so x is going to equal 2. We'd put that here in the corner. I'm going to take my I'm going to take my coefficient, so I'd have 3, negative 2, 5, negative 1. I would bring down that 3, and then I would multiply and add. Multiply and add. Multiply and add. And then at the end we would say, okay, if I was truly doing synthetic division, in the end when I go to write my answer, remember we said the last number is that remainder. So with the remainder theorem, all we actually care about with the synthetic division is that last number. So we do all of this, and instead of writing my answer, which we could, right, we could say, well, that's going to be 3x squared plus 4x plus 13 plus that remainder over the divisor. But the remainder theorem says, you know what, I could just divide by that factor, and the last number is the remainder. What it also means is that instead of doing all of this division, I could just simply take that same number and evaluate or plug it in. So now instead of doing all of this synthetic division, I'm just going to simply plug in that value that we got here in the divisor. I'm going to plug it into the equation. So I'm going to evaluate. And when I simplify this, I end up getting 25. So I notice that the number in the remainder of synthetic division is the same number I get when I simply plug it in. So that's what the remainder theorem says. So now you can say, well, if I want to find just the remainder, I could either use synthetic division and find the remainder, or I could simply plug it in to get that remainder. Okay? Now, the reason that we're doing this, remember the whole idea is to solve a polynomial. The reason we want to do this is because here in a little bit, when we actually start solving, we're going to realize that the remainder of 0 means that we have a solution. So, for example, if for this problem I had plugged in the 2 and my remainder was 0, then I would say 2 is a solution for that polynomial. So if I go and I either do synthetic division or I plug in and I get the remainder specifically to be 0, then the number that I plugged in would be a solution. Now in this case, we plugged it in and we did not get the remainder of 0, so therefore 2 is not a solution. But really the remainder theorem just gives you that option of saying, I can either do synthetic division or I could simply plug in the value to know what the remainder is.